Today we teach you something new. It's not complicated, but it is new. Okay, you don't have a basis for this. And so we will start with kind of the background. The operation to date is function inverses. Yesterday we talked about multiplication and division and addition and subtraction and absolute value and square roots and squares. Those were all operations that we used in mathematics. Yesterday we taught you a new operation. Do you remember what the new operation we taught you yesterday was? Composition, very good. And it looked like that, right? And we specifically did composition with functions. For example, we composed f of g. We did that yesterday. We learned what that was about. Well, inverses is like this, say f inverse. That's a new operation, and it only works with certain types of functions. It only works with functions that are one-to-one. And a function is said to be one-to-one if every input has exactly one output. And every output has exactly one input. Okay, so we'll do the example here, okay? We'll say that Nunu and Melissa are both waitresses. How does that sound? Okay, we'll say that they work a shift and they earn a certain amount of money. We'll say that Nunu earns $100 and we'll say Alyssa earns $200, okay? That's a function because they both produce one output, right? Let's switch it up now. Let's say that Nunu made $200. And let's say Alyssa made $200. That's still a function because they both produced one value. But suppose I asked you, which was the waitress that produced $200? You would say, well, I don't know, I can't tell you because they both had $200 that they produced. So therefore, they wouldn't be a one-to-one function. They're a function, they're just not one-to-one. So we don't know which output it goes to. So, for example, if the three of you were all playing a game of soccer and you all scored one goal, that's a function. But it's not one-to-one because I don't know which one of you scored just one goal. I don't have goalie. I have Keith. Keith? Short? No, is it going to be a short time?
Oh, yes.
Okay, excellent. Thank you. Okay, here we go. So we have a nice way to see if functions are one-to-one or not. And if they are one-to-one, they must pass the horizontal line test. So you can see that this function is not one-to-one. It does not pass the horizontal line test. So if I asked you, where is this function, where does it have a height of 0? You would be like, well, there's 3 spots where it has a height of 0. I don't know which one you're talking about. Whereas if I drew a different function in green, that one is one-to-one. If you ask me, where does that function equal 0, I'd say, well, there's only one spot where it equals 0. If you ask me, where does it have a height of 2, I'd say, well, there's only one spot that it has a height of 2, and that's right there. Okay? There's not multiple spots. There's just one spot. And so that makes it one-to-one. You don't have to do anything with one-to-one. You don't have to know about it. For those of you, there's a few people that are going to be taking college algebra next year. We get into more depth with that. And the fact that you see it here first kind of helps out. But so let's understand then what a function inverse is. So yesterday we talked about composition. Composition works with functions, Inverses only work with one-to-one functions. So everything we talk about today is going to be a one-to-one function. It would pass the horizontal line test if we were to graph it. So function inverse, what is it? Let's first talk about what it is not. F inverse is not 1 over f. That is not what it is. You don't put it on the bottom. It doesn't mean you're taking it to the -1 power. What a function inverse means is that the domain becomes the range, and that the range becomes the domain. They switch, or in other words, all of the x's trade places with all of the y's. All the x's trade places with all the y's, and all the y's trade places with all the x's. Okay? So to demonstrate, I'm going to give you the most basic function that I can think of in my brain. And I'm going to give you the function 1, 2, and 2, 3. That's my function. It is simply 2 points. If I have the function 1, 2, 2, 3, and I ask you what is f of 1, what that means is if I have an x value of 1, what is the y value that corresponds to it? If x is 1, y is 2. If I switched it and I said, what is f of 2? That means if I have an x value of 2, then what is the y value? And you can see that the y value is 3. But suppose I were to change that to f inverse. If I were to say, what is f inverse of 3? What that means is that 3 is not an x value. It means that 3 is a y value. So if the y value is 3, what's the x value that corresponds to it? 2, right here. And if I ask you f inverse of 2, that means that if I have not an x value of 2, but a y value of 2, the corresponding x value is 1. So inverse, instead of finding the y value, it finds the x value. And that's what an inverse is. We all good? So let's see some of the problems that you could get in your assignment as well as on your test. It says if f of 2 is 3, f of 1 is 9, f of -3 is 8, and f of 4 is 5, and it's a one-to-one function, I need to find these. F inverse of 8. That means that there's a y value of 8. If I look up here, if there's a y value of 8, that would be right here. That means that the x value would be -3. How about if I have a y value of 3? What would the x value be? 2. What if I have a y value of 5? What would the x value be?
4.
Good. And if I have y value of 9, the x value would be 1, so on and so forth. So can you see that if you were taking the ACT? Bella's going to take the ACT this year, right? Yeah? Okay. Parker, you going to take the ACT this year? Thinking about it? Not sure? Owen? Whatever they tell you to do, it's not required.
Yeah,
Yeah? Yes, you are? No, you're not.
whatever they tell me.
Whatever they tell you to do, okay? All right. Well, we can talk about that later, give you some advice one way or the other. But if you saw F inverse on the ACT before this year, you'd be like, shoot, I don't know what I'm doing. But now you're like, it's no big deal. You just grab the Y value. Get my point? So sometimes it's just a little bit of notation that you need to learn in order to help you with a couple points. Example number 2 says, given f of x is 3x minus 8, find f inverse of 6. So what that means is I have a y value of 6. You are looking for the x value. Okay? So I have an x value I'm searching for. I know that y is 6. So I'm going to take 6 and plug it into the output. I go ahead and I add 8 to both sides, and I get 14 is equal to 3x. I divide by 3, and I get x is 14/3. In this next example, it says find the inverses of the following functions. Now we don't just want a number, we want an actual function that outputs. And the way that we do this is f of x is equal to 2x minus 5. We write it as y equals 2x minus 5. So I don't have a number I'm plugging in for x or y this time. But to find the inverse, we do what we talked about right here, okay? We switch the x's and the y's. So I'm going to take this and I'm going to switch the x and the y, and I'll write x equals 2y minus 5. X equals 2y minus 5. And then I just solve that for x. So I add 5, or I'm sorry, I solve for y. So I add 5 to both sides. And when I do, I get x plus 5 is equal to 2y. And then to solve for y, I divide both sides by 2. And I get x is equal to, I'm sorry, y is equal to x plus 5, that quantity divided by 2. If you wanted to write this differently, if you want to write it as 1/2 x plus 5 halves, that's fine. These are the same. I don't care which one you write. They're both equivalent to each other. That's up to you. Try the second one on your own, okay? Switch the x's and the y's and solve for y. Come on in.
I have a huge favor to ask your class.
Yeah.
Does anybody in here have an iPhone charger? Shooting. Okay.
I had one, and I think I
Okay.
gave it, or I think I accidentally had one of Mr. Chalmers at one point.
Okay.
I know Mr. Luther doesn't have an iPhone, but Netiwa always does, but she's not here.
Okay.
Sorry.
No, it's okay.
Good luck.
Pleasure. Do you have an iPhone?
I switch the x and the y, and I get x is equal to 6 minus y, or 4y. You subtract the 6, I have x minus 6 is equal to negative 4y, divide by negative 4, and so you get y is equal to x minus 6 over negative 4. Did anybody write it differently than that? Are we all okay with writing it like that? Okay, sweet. Or the other side, we'll finish off these and you guys can work on your assignment. This one is different because it has a cube. We don't need to be afraid. We can handle it. Y is equal to x cubed plus 1. And I'm going to switch the x and the y. And if I do, I get x is equal to y cubed plus 1. And now I'm going to solve for y. What would be my first step for solving for y?
Subtracting 1.
Yep, subtract the 1, and I get x minus 1 is equal to y cubed. How do I get rid of a cube?
Cube the other side.
Close. If it was a squared, what would you do to get rid of a squared? You would take the square root. So to get rid of a cube, I take the cube root. So I'm going to cube root both sides. And I get y is equal to the cubed root of x minus 1. This one, y is equal to x over 5. I will rewrite this one as y over 1. I'm sorry. X over 1 is equal to y over 5. And I wrote it as a fraction because the other side is a fraction. So I'm going to cross multiply, and I get y is equal to 5x. And that is the inverse of that one. We could spend 3 to 4 days on inverses. We're spending just 1. The idea is you want to see it so you're familiar with it, and then if you see it next year, you're not afraid of it. The last thing we want to do is flip over to the other side again, and we want to be able to test to see if something is an inverse. So I'm going to give you an example of a couple of inverses. For example, 3 and -3, they are inverses under addition. Because if you add them together, you get 0. So 10 and -10 are inverses under the operation of addition. 1/4 and 4 are inverses under multiplication, because if you multiply them, you get 1. So that is the inverse, or those are inverses under multiplication. So 0 is a special number, 1 is a special number, 0 is special for addition, 1 special for multiplication. Well, when it comes to inverses, it turns out that the way you test to see if they're inverses is you compose them together, like we did yesterday. F of g of x should produce x. So it doesn't produce 0, it doesn't produce 1, it produces x. And you have to compose it both ways. F of g is x, or f of g of x is x, and g of f of x is equal to x. So let's compose these and see if we get x. It says to use the property of inverses to determine if they are inverses of each other. And that means that we will compose these together. F composed of G and G composed of F. So Caitlin and Claire, this is a little bit of the lesson that we had yesterday, okay? And F composed of G means that I take what G is and I plug it in for X in the function of F. And when I do that, I get 3 times, and instead of X, I write X plus 5 divided by 3. And then I have a minus 5. Notice that as I'm multiplying by 3, this is like a 3 over 1. If I multiply, the 3 on top and the 3 on bottom will reduce. And I'll be left with x plus 5 minus 5. And what does x plus 5 minus 5 reduce to?
X.
Just x. That's good news. That means that they are probably inverses. In order to show that they are, I have to compose them the other way as well. So now I do g of f. So Caitlin, that means I'm going to take f and I'm going to plug it in for g. I'm going to take f and I'm going to drop it right there. And so this is going to produce the quantity 3x minus 5 plus 5, all divided by 3. Notice in the first one, I eliminated the 3's right away, and then I was able to eliminate the 5's. Here, I can't cancel the 3's right away. I first must reduce the 5's. A negative 5 and a positive 5 will make 0. So this makes 3x over 3. And 3x divided by 3 is just x. So because they both produced x, they are inverses of each other. Last set, f of g and g of f. For the first one, which do I grab first? Do I grab the cubed root of x, or do I grab x cubed? Yep, since this is f of g, I grab the cubed root of x, and I plug it right in there. So I get the cubed root of x cubed. What happens if you cube a cubed root? They cancel, I'm just left with x. Then I have g of f. That means I'm going to take this and I'm going to drop it in there. and I get the cubed root of x cubed. What happens if you take the cubed root of x cubed? They cancel, and I'm left with x. So because I get x in both situations, they are inverses of each other. So your assignment reflects those tasks. I know it's almost 3 o'clock, and you're probably ready to be done with the day. Some of you are ready to take a nap. I hear you. I'm tired too. But you will persevere and maybe get a problem or two done.